Howdy everyone. Today we're talking tree traversal. Well, we're going to realize that tree traversal is not so bad because all it takes is understanding a few definitions and some algorithms. So first, let's define what it means to traverse a tree. Traversing a tree means visiting all of the nodes in a tree in a particular order depending on the type of traversal we're doing. So in today's video we're going to talk three of the main traversals: preorder, inorder, and postorder traversal. The main difference between these three algorithms is when we visit the root/current node. So to see what I mean, let's look at one of the algorithms. First, let's start with preorder traversal. Its algorithm goes like this. Step 1. Visit the root/current node. Step 2. Visit the left node, and thus the left subtree. Step 3. Visit the right node, and thus the right subtree. I'll describe what that means. So this is a recursive algorithm, which means at each node we're going to make a call to this algorithm. We're going to visit the root node, and then we're going to call this algorithm again, and basically every single node will do these three same checks. They're going to check themselves, their left, and then their right, and then go all around the tree until all the nodes have been visited. And preorder, its name comes from the fact that we visit the root/current first, pre everything else. So, who would I be if I didn't have a big old example? We're going to go through this tree step by step and just do a preorder traversal. Okay, with every traversal, it's important to note that we always start at the root of the tree. We only really have a reference to the root of the tree unless you had more pointers or whatever. But okay, we're at 4, the node. And then let's recall our 3 steps, our algorithm. Current, then left subtree, and then the right subtree. Or just the left and right node. But we eventually look at the whole subtree. And you'll see what I mean after we go through the example. So, step 1, we visit current. So let's mark 4 as visited. Then we can go left. And at left, boom, recursion time. 2 will make the call to this recursive algorithm. 2 will become current, mark itself as visited, and then it'll check left. We'll see nothing to the left and we'll ignore it, and then we can go to step 3 and check right, and we can mark this is, well, we're not going to mark it yet. We're going to call this the new current. Now 3 will mark itself current, check left and right, there's nothing there. Bam, we're done. So what we just did was 4 made that call in the algorithm to check itself and then left. And what we did was we checked the left node, but the left node 2 also made more calls and more calls and more calls until everything in this left subtree was visited. And that's just a result of recursion. We kept doing all our steps until we made it to a leaf. A leaf is a node that has no children in a tree. And now, you can guess, we're going to do the exact same thing, but on the right of the tree. So, 6 becomes our new current. And step 1 is fulfilled, we visit it. Then we can check left, 5, and we'll mark 5 as visited. And left and right subtree are null, so we just ignore them. And the same goes for 7, we mark it as visited, and then we're done. This is our preorder traversal. Not too bad. With more practice, this will come a lot easier. And in the top left, I have been keeping track of the order that we've seen all the nodes. So I guess it's important to talk about the other traversals and how they differ. Inorder differs slightly. What we do here is, instead of visiting current first, the first node we visit is the left node, and then the current node, and then the right node. This is called inorder because we visit root node in between left and right. So it'd be kind of like reading a binary tree from left to right. And with binary search trees, it ends up being in order. The order of the nodes that we visit are ascending. And we'll see after we traverse this tree. Who would I be if we didn't have a drawn out, but hopefully thorough example of a tree traversal? So let's recall our steps. We always start at the root node, but step 1 says look left. Okay, we're going to look left. Recursion again. Now we should look left again. We see nothing there, so then we can go back to current and mark 2 as visited. And now we can go to the right. See nothing on the left. Mark 3 as current, mark that as visited. Go to the right, nothing there, and we're done. That's our left subtree. We did the algorithm on every node, breaking down the subtree into just smaller and smaller bits until we got to a leaf. Now finally, 4 is our current, back to the original caller. We can finally mark this as visited. Bam. Now step 3, we're going to look at the right of 4. And it's just the same thing. We're going to call our algorithm. 6, look to the left. Current, see nothing to the left. Mark 5 as visited. Look to the right, nothing there. And then we can go back to current at 6. Mark this as visited. And then go to 7. We should check left, see nothing there. Mark 7 is visited. Check to the right, nothing there. And then we're done. This is your inorder traversal of this tree. And as I mentioned earlier, we visited this binary search tree in order, and in the top left I have our visited array. It's in ascending order. So finally, now we can talk about postorder traversal. Postorder traversal differs in that the last node we visit in our algorithm is the root node. So we might have visited left or mid for our first step, and then the right node. And it's important to note that left always comes before the right node, depending, like on all the algorithms. But the main difference between all the traversals is when we see root node. And it just happens in postorder that the last node we visit is post everything on the left, everything on the right. Then we see root. So one more example, just one more. Start at root, don't forget our steps. 1, look to the left. We should look to the left again, see nothing there. Instead of going to current, we're going to look right. And 3 will make that recursive call. Check left, check right, nothing there. Finally, we can go to current 3, visit that. Then we go back up the recursive stack to 2. This is current, and we can mark this as visited. And we just finished the entire recursive call to the left of 4. Now we're going to make a recursive call to the right of 4 with 6. And 6 is going to make a recursive call to 5. Now 5 is going to check left and right. But it's a leaf and there's nothing there. So then we can mark 5 as visited and we'll go back up the recursive call stack to 6, who then will make a call to the right because that's step 2 of this algorithm. 7 is also a leaf, nothing in the left or right. So then we can finally mark 7 as visited. We can go back to 6 again. 6 is visited, and finally we can go back to 4 and mark 4 as visited, because it was our original current. It was the original one who called left and then called right, and we finally get our time to give some attention to 4. So here is our post-order traversal of the same tree. I use the same tree in all of them. Woohoo. And here is a summary of what the traversals look like. Some cool things to note, I guess. You can just look at the array and you can tell which traversal was which. If you didn't know it was preorder and inorder or postorder, but if you had a picture of the tree, you would know preorder because the first node we visit is the root node, and inorder is not, and then postorder, the root node, is the very last node we visit, because that's how the algorithm goes. The algorithm says that the last node we'd visit is root. Another thing that's important, that's an interesting, neat fact, is that 7 is the last node we visited in preorder and inorder, but that's the rightmost node of the tree, because that's what it specifies to do in our algorithm. We visit the right subtree last, and so 7 would be the very last subtree, the last right leaf. Let me see, do I have anything else to say? I guess give some practice. I highly recommend, hopefully, going back and pausing the video, trying to do the traversals yourself if you can do them out, and then follow along with my steps. I hope to make my next video an exam question that I had in my class. See if I can actually do it, since it's been a whole semester since I've taken the class. Describe my thought process, have it live, and yeah. So that was it for today's video. Thanks for tuning in. I hope that was helpful, and stay safe, everyone.